Hello, my name is Leandro Abram. I'm from Mendoza, Argentina. I'm a software engineer with knowledge and specialization in artificial intelligence and data science. I have about 5 years of experience working in data science and artificial intelligence projects. And here I'm gonna guide you through a project called How to Retrieve Images by Visual Similarity using deep learn features with Python and Keras. It's a very simple project. It will cover the basics to learn how to find the most visual similar images from a group of images to a query one, using the Python language over a UNIX operating system, either a Mac or a Linux system. You'll be guided through the process of setting a minimal environment and implement the scripts to achieve this objective. You will learn how to use a pre-trained deep model from the Keras library. It's a Python library of deep learning to generate a vector representation of each image, and this vector representation will then be used to find similar images to a query one. So the requirements for this tutorial are getting or having basics knowledge of Python programming, using a Unix operating systems, as I told you, either a Mac or a Ubuntu or Linux. You have to know the basic of using command line on Unix, and you have to have pre-installed the virtualenv tool of Unix in your system. This project is aimed to people who feel experience in artificial intelligence in order to have the first steps in this area. The people who want to start learning the basics of deep learning models, and it will help to make the first steps towards maybe the implementation of an image search engine. This project will have 5 sessions. On the first session we will set up the environment. It's a very simple session. We will create a folder for our Python scripts. We will create a virtual environment in this folder in order to encapsulate the package installation, so we cannot interfere with other packages in our system, and we will install the Python package needed for the project. In the session 2 we have a little session about a bit of theory about deep learning, the basics to know what is deep learning, why it is used, how it is used in computer vision, and what is the BGG16 neural network, that is the one we are going to use to characterize our images, well, how we can use it to generate a vector representation or a feature vector representation of the images. In the session 3 we will implement a Python class in order to encapsulate the code of generating a vector representation for an image, so we can reuse this code and save effort. We will learn how to import or get this model from Keras, preprocess the images, and use this model that has been pre-trained in another task to generate a vectorized representation for the images. Then in session 4 we will implement a Python script that will read a folder with images and index them or store them in a CSV file as a kind of database. We will read each of the images, use the class that we implemented earlier to generate the feature vector representation, and save this information to a CSV file that we then use as a database of our images. Then finally in session 5 we will implement another Python script that we should pass a query image, and this script will read this image, characterize it using the class that we implemented earlier, generate this feature vector, and then read the CSV file, the database, extract the feature vectors of all the images, and measure the distance between this query image and each of the stored images, and retrieve or show the most similar images in screen, like using the pipeline library. So that will be all our project. It will be very simple, but it's useful to learn the basics of using Keras, a deep learning model, and learn a bit about how to search image by similarity. Thanks. Well, hello, welcome to this session. Here we will install the needed packages and putting the environment to work. As we were working with Python scripts, we just need a text editor to work with the scripts and just to install packages, but we won't use a complicated IDE or something like that. So the first thing to do is like to create a folder where we will work. I call it, for example, img reader, and we go into this folder. Well, after that, as we will be working with Python, a common practice when you program Python project is to use virtual environments. In short, a virtual environment is a kind of encapsulation of a package installation, so that you can have multiple projects with different versions of Python or different versions of the packages, and not to interfere each other. So in this case, you just have to install a tool called virtualenv or something. There are a few ways of creating virtual environments, and here we will use virtualenv. And you call this command line. You specify with the argument -p that for this project we will be using Python 3, the version 3 of Python. Then you give a name of the virtual environment, for example bemb, and this here it will create a folder called bemb where all the packages will be installed. As you will see, you have this folder. So in order to work with your scripts and with this virtual environment, you have to activate it. That is very important. You don't have to forget, because maybe it won't work if you don't activate it. And to make that, you call source, and you find in the bemb folder, then in the bin folder, a file called activate. So here, this text here indicates that you are working on the virtual environment. So any installation of package you want to do, you do it with this virtual environment activated, and any running of the process, you do it with this virtual environment activated. Well, as you will see, here we will install the packages using the pip tool. But first, let me copy a file. Well, here in this file called requirements.txt, I have already put the name of the packages of the Python packages we need for this project. So then would be very simple to install all of them together. The Keras packages, as we mentioned, we will work with a deep learning model, and Keras is a framework of deep learning from where we will took the BGG model pre-trained. Then Keras uses another library as a backend called TensorFlow. All of you must have heard of it. Then we also have the pandas package because it works with data. It's called the data analysis. It's a data analysis package, and we will use it to read and work with the CSV file. Then Pillow is a package of working with images. We will need it to read the images and process them. Matplotlib, it's a library for plotting, and we will use it as a way to show the images we query. And then SciPy and NumPy are numerical and scientific packages that we will use in some of our scripts. So with this file existing, you just call pip install -r and you pass on the file and it should work. It's like looking from the internet all the packages and install it for your operating system. In my case, it looks for the macOS packages, but if you it will search packages for Linux. Well, this it continues searching and installing. Well, let's see if it finish all the installation. And well, when you have these packages installed, you will be able to import these packages in your script. As you will see, then our project will look like this. I'm here using a Sublime text editor. It's very nice text editor and very simple. And we will go through these 3 files or scripts later, but here we have all the code. And here, well, the first thing we do is to import the packages we have installed. So the project will work with these 3 files. The feature expert, it's a class, and 2 scripts, one to generate the dataset and one to find images in the dataset. Well, I think that's all. And well, you have now your environment installed. Here in this folder you should put your script files. Well, thanks, and we will see. Well, hello, welcome to this new session. Here we will implement a very simple class in Python language that we will use then to generate these feature vectors for each image in order to represent them in a space that all are similar, or very similar, or expected to be similar. It's a very simple the BGG16 model. It's a model it's already implemented all the specific layers and all these things of the BGG16 neural network are already implemented. We also import a package for working with images and for pre-processing inputs, and also we maybe need this other library, NumPy. It's a package of Python to work with numerical vectors. Also, we define the class, and we'll define a variable of class called model, where we will have our BGG network. On the constructor, it's very simple also. We instantiate this variable with the BGG16 neural networks. Here the parameter that we pass is the weights used. We told to the instantiation of the network that we will load a pre-trained network on the dataset ImageNet. As I told you earlier, it's a big dataset of a lot of millions of images. And calling this, we are telling the network to be pre-trained on classification in this dataset. And with this parameter, that's the important thing. We told with these two parameters, we told that we won't use the last layer, the classification layer, where we decide what class is, but we will use in the previous layer to the last one. So the last layer of this punctual network will be a vector of variables. So we implemented also a feature vector method, getFeatureVector, where we will pass an image that will be read in another script. So we passed as a parameter, and we here do a series of pre-processing steps needed to use this model in order to get the feature vector. The image first is transformed to an array, because the image must have, for example, it will be a matrix of or three matrices containing the RGB channels and the pixels for each channel. Then it's transformed to an array, to an array, or a data kind of data array, and then it's flattened as a big vector of variables, so it can be input to the network, because the network receives this kind of data, this format of data, and then some pre-processing is performed, needed to adequate the input to the expected by the model. Then, using just the instance variable called model, we call the method predict. If we were using the complete BGG16 neural network, with the predict we will have a class or a group of classes, but now as we took out the last layer of the neural network, we're just having a feature of vector, and then that is what we return to the point where it's called. So the idea is to reuse this code, and this code, well, so we encapsulate it in a class, in an expert class, so that it can be called from other places, like the Python script to generate the database, or the Python script to retrieve similar images. Well, we will see when you run this code, you will see that, for example, this line will maybe call for download the model if you don't have in your PC, but well, that's only the first time. We will see it working when we implement the Python script to generate the feature vectors, and the other Python script. Well, I hope you could understand all the process. It's very short class, but the idea is to reuse code, so we encapsulate all this code in this class vector class method, so we can call it from everywhere and not copy and paste the code in every place. So, well, thanks, and we will see in our next session. Hello, welcome to this new session. We will here learn the basics of deep learning. We will have very little theoretical knowledge about the field. It's a very deep field. It has a lot of things to learn, but we will see just the basics in this session in order to know what we're doing in our project. So, well, first we need to know what is machine learning, because deep learning is a subfield, or is a specialization of machine learning. The idea with machine learning is that we have a machine learning algorithm that must learn a representation between a group of pieces of data, like, for example, documents, images, sounds, or texts, and learn a predictive model that it can predict a label. So in order to machine learning learns about this group of examples, each example must be represented as a vector of variables, of a vector of numbers, of or called vector feature vector or vector of features. So this mapping is learned between this vector of variables and a label, for example, a number or a category. Well, then, when a new document or text or image comes, we apply this feature extraction and generate a new feature vector so that we pass it to the predictive model and it predicts the expected label. Well, here's the important thing: the feature vectors that are a vector numerical representation of a piece of data, for example, in our case, of images. So we won't use a machine learning algorithm, but we will use feature vector representation to find images similar to a query one. And well, what is deep learning? Deep learning is a kind of model in machine learning. It consists of deep neural networks, but well, the neural network is a model where we have a series of inputs. Here, the feature vector are passed commonly, and these are connected with another called input hidden neurons, that each neuron here summarize information of all its inputs, like a weighted sum, for example. Well, then it's connected with another layer that also summarize information about all the previous layers and so on. So the idea is in a deep neural network that we have a lot of layers. So more complex functions between this input, the red dots, and the outputs, the blue dots, can be learned. The idea is that in each layer, the weighted sum of the previous layer is input to the layer and is processed and output for the following layer. It is not necessary to learn in deep this, but well, this is the main idea. So we have an input layer, a series of hidden layers, and an output layer where the output is predicted. Well, the main idea or the main importance of deep learning is that this feature extraction process where we generate, for example, the input is an image of a car, we actually, or in the past, the features were manually designed and they were extracted and input to neural network, for example, for classification, to say it's a car or not, or it's not a car. Where with deep learning, the idea is that this feature extraction is embedded in the process, so the big neural network can learn this feature extraction, this feature representation, and generally this feature representation of this vector feature is the layer previous to the last layer. So with deep learning, we can automatically learn feature representation and not design them manually. The idea is in any machine learning or deep learning algorithm is that, well, you have a big set of training examples, for example, a lot of images, and they are input to the network. The information is passed forward, and then you have a label, and the network try to guess what is in the image. In the case of image classification, and then the error between the expected and the predicted label is calculated, and then the information is going backward to adjust a series of numbers of the network in order to perform this task correctly. So then, as I mentioned, in the inference pass, in the inference time, we had a new image and it is passed forward the network in order to get the label. Well, in the previous layer of the network, we can have this vector of variables. Let's go to an example. For example, the BGG 16 neural network is a convolutional neural network. It uses a special kind of layer that are convolutions. But the main idea is that you have a lot of these layers, and in the end we have a softmax. This layer is just one that transforms the feature vector representation into one or multiple classes. Well, in our work, in this project, we will take out this last layer. So we have as last layer this one, and this one is a vector representation of an image. So it's used as a feature vector, and this feature vector is the one what we use to find similar images. It's supposed that if I pass here to the network a cat, at the end I will have a vector of variables that if I pass another cat, these two vector of variables will be similar. But if I pass a car, for example, or a guitar, these vector of variables will be different from the car ones or from the cat ones. So the idea is use this network that to produce these feature vectors, taking out the last layer that it's the one in charge of classifying an image. Well, the BGG network that we will be using is pre-trained with a group of a big set of images called ImageNet, and it's trained for the purpose of classification. It's trained to learn how to differentiate a car from a person, from a chair, for example. So it's expected that this layer produce feature vector representation that represents univocally the class of objects. So when we search, for example, for we present to the network an image of a cat, it will, using this representation, we will find similar images like, for example, the cat. So, well, it's all for this session, and I hope you could understand, and, well, we will see in the next session. Well, hello, welcome to this new session. Here we will walk through the implementation of a Python script that will read folder where we have all our images to index and generate a CSV file that it's kind of database of our images, and they are a vector representation. So, well, it's very simple script. Also, we have some imports here. We import the argparse package in order to read arguments from command line. We import these two packages, OS and glob, to walk through the data, so through the folder of images. We import the CSV package to write to a CSV file, and the Keras processing and this package of the Keras library to process and read images. And you can see here the import of our feature expert, the class that we implemented earlier. It's imported here in this script. As you will see, this is my working folder of my project, and here it's the feature expert in the same path, so we can import without problems. Well, the main method it's called when we call by command line this script, and then the first we do is to parse the arguments. We have two arguments: the dataset path, where we have all the images to read and index, and the output CSV, where we want to write the feature vectors of each of the images. We will see here that I have this folder called dataset, and I have a lot of images. These images were extracted from the Caltech dataset, and you can here put all the images you want. And well, then we instantiate here the feature expert in order to use it then later, and here we just instantiate a class of this of an object of this class. And then the main code is just for loop. It iterates over the files of the image files in the of the JPG files on the dataset path. It first read the image as a 224 by 224 matrix or image. It shrinks it to that size. Then we just call the method that we implemented earlier in the feature expert class to get a feature vector of the image. Here the idea is to transform the feature vector. This is a 1 by 512 matrix, so we have to get the first line, the line 0. That's why we put this index here, the 0 index, and we transform it to a list in order to then build a list that have these 512 variables or numbers, and also the name of the file, the name of the image. So then we open the output CSV as an append mode, and we just write this file, this line. In this line, we write a line in the CSV file, and well, that for all the images we write a line. We will see it in action, like calling just Python dataset generator. As I'm not passing argument, it's using the default parameters, the dataset folder as input folder, and the dataset.csv as the default output file. And then you will see how it's using. Well, this is the backend that's using, and it's reading and getting the feature of each image. We will see here how these feature vectors are being added to the CSV file. It's kind of messy, but well, I'll show you. This process is very long if you have a lot of images, but well, you will see here in the root folder, you will see the dataset generated. It's just a lot of numbers, and at the end we have here at the end we will have the name of the image. So then we can read this CSV file and know what is the vector representation and which is the image. Well, that's for this session, and then we will see how to use this CSV dataset to find on it similar images to a query one. Well, hello, welcome to this new session. In this session we will go through a script that is used to find similar images, like a query one. Here it's similar to the other script we saw. We have the import of the libraries like the argparse, the Keras library. Here we also use pandas and numpy, two other and scipy, to three scientific libraries. We will see why we use them. Well, we have also an import from matplotlib in order to plot the images, and as we saw earlier, we have the import to the feature expert class in order to generate the feature vector from the images. So while the main method here is similar to the other script, we have three arguments to this script. We have the query image. It's the name or the path of the image that we want to find an image similar to. We have the number of similar images we want to retrieve, and we also have to specify the name of the dataset, the name of the data CSV that we generated earlier. So after parsing all these arguments, we read first the query image and load it in the variable as we made earlier. We instantiate the feature expert and we call the method to get the feature vector from the images using the class that we implemented. Then with pandas, here's just pandas, we read the dataset, the CSV file, into a data frame, and then with this line we extract all the lines of the dataset and all the columns without the last one, because in the last one we had the names of the images and we here want to extract that's the features, and we transform this as an array, an numpy array. Well, then this line is the most important because it estimates the distance. This function setDist estimates the distance, the Euclidean distance between two vector variables. So as we are working with two arrays, it works vectorized, so we don't have to do a for loop, and we just call it, and in this variable we have the distance of the features of the query image to the features of all the images in the dataset. Then this variable can be sorted, and well, we have the indexes. So we have the indexes in the order that they index the most close images to the further images in visual similarity space or in feature space. Well, then here we have just a list where we will put the images to plot. So the first image of the array is the query image in order to look how it looks, and then we made a for loop and we query, or we load here we extract the name of the similar image from the dataset, because we look it in the location of the sorted index corresponding, and we load it here and append it to the list. So after that we call this plot images function that is implemented here. It's a function that generates a figure here, and then iterates over the images and add subplots in order to show each of the images. So we will see when we run this code that in the screen we will see first the query image and then all the queried images, the similar images found by our algorithm. So we will run it here. We run it in the source directory. We call the script. We call as a query image one of an airplane. We mentioned that the dataset file name is datasetfull.csv. This is the name of my dataset, and we ask to query 15 similar images. So when we run this, it has found these 15 similar images. They're all airplanes, and we will see them in the screen. As we can see, the first one is the one that we already queried, because they are the same and they have the same feature vector. And then we have all more or less similar images, so more or less similar. At least they are all planes, and they are more or less similar as we expected. We can do it, for example, with an image of a revolver. It's all the process, and then, well, we had all similar images, like all revolvers. We can do it with an elephant. Here, and you will see that there is no so good. It is not so good, but because the elephant image we choose, it's like like a toy, and here are similar images but not of the same category. But we have some elephants in the results, some similar elephants. Well, I think that's all for this session. I hope you understand, and well, I hope it's useful for you.